In problem number 1 in 6.7 on Bayes' theorem, here's what we're asked here. We're given this insurance company has determined the accident rate. So depending on ages, here's the accident rate and the total number of people that are insured in those ages. And then we're told that suppose a policyholder calls in to report an accident. So that's given information. So somebody reports an accident. So an accident is given, and then what is the probability that that person in the accident is over 60? So here's what we're looking for here. What is the probability of being over 60? You know what? We need a notation. So how about 60 plus, given that an accident has been reported? So I'm going to put an A for accident. So the first problem we have here is just what kind of notation do we want? We're given that there's an accident, so I used an A. And we're given that we want the probability of being over 60, so I used 60 plus. So you just have to make up some notation for yourself. And in the denominator, we're going to divide by the probability of the event that's given. So what's given here is the probability of A. We're going to divide by the probability of A. Now what we need to do is get these numbers here and these numbers here. And we can do that from the tree diagram. And I think to draw this tree diagram, I'm pretty much going to draw it like this. This will be my first. I'll start here and branch out using these numbers, and then we'll branch out again, getting the accident rate. So let's try this. So this is going to look maybe like this. We're going to have 1, 2, 3, 4, 5, 6 branches. I'm going to put nodes on here. And each branch corresponds to an age group. So now I can mark these someplace and somehow, and the way I'm going to mark them is maybe this. This is the age group under 21, so let's say less than 21. This will be 21 to 30. So how about just 21 to 30? I'm just going to write it like that. I just need to somehow remind myself that that's what this is. So this branch right here, that's going to be in this group, 31 to 40. And why don't we write it like this, just 31 to 40, just to remind us what it is. This branch right here goes this area here, 41 to 50. So let's write 41 to 50, and then 51 to 60, and then 60 plus. Now, what's the probability of being on this branch right here? This is under 21. The problem tells us that being under 21, the proportion of people there is 0.05. So let's put in a 0.05 here. Probability along that branch is 0.05. And then just filling in our other branches, right, I'm going to put a 0.10 here because the 0.10 is coming from this, 21 to 30, and being in that branch is 21 to 30. In this area, in this age range right here, that's going to be 25%. We'll put a 25% there, a 20% here, 30% here, right? The 30% is coming from over here. And finally, the 10% down here coming from being over 60. Now, being in each age range on each one of these branches, from here, people in this age range can get into an accident or not an accident. So let's record those. So probability of getting into an accident here, let's draw that. This is going to be, say, A for accident, and I'll write an A prime for no accident. And the probability of being an accident here, now that's given right here, right? The accident rate is 0.06. So this is going to be 0.06, and this must be 0.94. You're either in an accident or you're not. These have to add up to 100%. So let's go into this age range here, 21 to 30, and we can, if you're in that range, you can either get into, this is going to be tight here, this is an accident or no accident, and the probability of being in an accident here for this group is 4%. So this right here, we'll write an 0.04 and a 0.96 here. And for this age group here, this is 31 to 40, all right, 31 to 40, the accident rate is 0.02. So the probability of being in an accident in that range is 0.02. This is going to be 0.98. And let's fill the rest of these in. In this range right here, 41 to 50, that accident rate, 41 to 50, is 0.015. So I'll put an 0.015 here, and then that must mean that this one down here, those have to add up to 1. How about 985? In this range here, 51 to 60, accident, no accident. And our rate right here, 51 to 60, is 0.025, 0.025. So the probability of not being an accident, 1 minus that 0.025, is 0.975. And then finally, we're here for being over 60, the probability of being in an accident is 0.04, so this must be a 0.96. So now I think we've got enough to get these numbers here. We can get this number right here, 60 plus and A. Where is that? That's right here. Oh, 60 plus and A is down here. 60 plus and A, this branch and this branch. So we can get these numbers as an and, so we're going to multiply right here. So let's do that. Now we're going to need a pretty big fraction bar here. So let me write that fraction bar. So big, long fraction bar to capture all of this. And on the numerator, that's where we're going here, right? 60 plus an A is right here and right here. So this is going to be the 0.10 times the 0.04. Now in the denominator, we're trying to get the probability of A. What's the probability of an accident? So how can we get an accident? Well, look at where all the A's are. There's an A here, there's an A here, an A here, an A here, an A here, and an A here, right? In each one of those age ranges, there's a possibility of an accident. Okay, so let's just get to them. How do we get to this A right here? It's this branch and this branch. So that's going to be the 0.05 and times the 0.06. So down here in our denominator, our first term might be 0.05 times 0.06. Or, right, or, because we could be here or here, and or is going to give us the plus. So plus, and then we could be on this branch here, the 0.10 to the 0.04. So let's draw that in. The 0.10 times the 0.04. Then let's get these other A's. So we could get an A here, right? The 0.25 times the 0.02 in this branch right here. So we're going to get the plus 0.25 times 0.02. And then this branch right down here, 0.20 times 0.015. So let's get that in. 0.20 times 0.015. Then this branch here, 0.30 times 0.025, so let's get that, plus 0.30 times 0.025. And finally, that last branch, which matches the top. Remember, in this Bayes theorem, one of these, in Bayes theorem as well as conditional probability, one term in the denominator will match the term in the top. And that's going to be our last one here, which is the 0.10. Let's get it to right here, 0.10 times 0.04. And then when I very carefully did this with my calculator, I ended up with this, the 4 decimal places, 0.1509.